So you want to own a data center, not rent a rack inside one. Own it. Your name on the fence, your slab, your transformers humming behind the trees. The picks and shovels of the entire artificial intelligence boom. And on paper, this is the best landlord business ever invented. Your tenants are the richest companies in human history. They sign for 10 and 15 years. And in the biggest market on earth, the building is full before anyone pours the foundation. That's the brochure. Now go and try to plug it in. Northern Virginia is the largest data center market in the world. Last year, it ended with a vacancy rate of 0.5%, and 96% of everything scheduled for this year was already spoken for. 0.5%. There is effectively nothing available at any price in the place everyone wants to be. So build one. You can put up a data center in about 2 years. You'll wait about 7 for the power to run it. Now, hold that next to this. In the same period, one of the biggest buyers on the planet reportedly walked away from a couple of 100 megawatts of leases it had already signed and paused a half-built project, weeks after announcing $80 billion of spending on exactly this. Microsoft's chief executive said it out loud. There'll be an overbuild. And a third number from the company selling the shovels. NVIDIA's data center business made $193 billion last year at a gross margin of about 75%. 3 of every $4 kept. No vacancy anywhere. Canceled leases. And the supplier keeping 3/4 of the money. Those 3 facts do not fit together until you see what this business actually is. Because it isn't a technology business. It's a real estate business wrapped around an electricity contract, and there are 3 people standing in front of you in the queue to get paid. By the end, you'll know who they are, why the most valuable thing on the site isn't the building or the computers, and why the greatest risk to a billion-dollar facility is a county board meeting on a Tuesday night. Let's start with the price of admission. Data centers aren't priced by the square foot. They're priced by the megawatt, by how much electricity they can eat, which tells you what you're really buying. Industry estimates put a conventional hyperscale build at $10 to $12 million per megawatt. But you're not building conventional. You're building for artificial intelligence, and those racks run hot enough that air can't cool them. Goldman Sachs research estimates AI-ready facilities cost 15 to 20 million per megawatt. So run the arithmetic. 100 megawatts, a normal size now. Shell and core alone, roughly $1 billion. Fully fitted, with the electrical gear and the liquid cooling. Industry estimates put it at 1.5 to over $2 billion. $2 billion. For a shed. A very sophisticated shed in a field that most people driving past will assume is a warehouse. And here's what's strange about where that money goes. Industry estimates say the mechanical and electrical systems, power distribution, cooling, backup, can swallow up to half the entire construction budget. Half the building's cost is the plumbing for electricity. The computers aren't even in that number. You buy those separately, and we'll get to what happens to them. At the top end, this industry has stopped speaking in megawatts at all. Campuses are now planned in gigawatts, 1,000 megawatts at a time, with headline figures of $45 to $55 billion per gigawatt, fully built out. Last year, spending on data center construction in the United States hit a record $50 billion in past office construction. America now builds more rooms for computers than rooms for people who work. And nobody writes these checks from a bank account. One AI cloud company raised roughly $28 billion of equity and debt in a single year. Do the math. It raises money faster than most countries raise taxes to buy machines that plug into a wall. You've signed. The land is yours. The slab is poured. The steel is up. There's just one thing left. And it's the thing the brochure never mentions. You need the electricity, and the electricity is not for sale. Every other business in this series burns money on people. A theme park hires 7,000. A hotel runs on housekeepers. A data center is the opposite, a $2 billion building with almost nobody inside it. What it burns instead is power. Continuously. Its whole existence is converting electricity into computation and heat, and the meter never stops because the machines never stop. No closing time, no off-season, no rainy Tuesday where you spend less. Then there's the heat. Those racks are so dense that fans stopped being enough. The industry moved to liquid, pumping coolant directly to the chips. Your building now contains plumbing that, if it fails, destroys the most expensive thing you own. And the equipment that connects you to the grid at all? Large power transformers run 2 to 4 year lead times from most manufacturers. You can have the money, the land, the permits, the tenant, and the chips, and still not have a data center because a steel box the size of shipping container is on backorder until the year after next. Here's the thing nobody tells you about this business. Almost every constraint in it is physical, and none of them care how much money you have. Not the queue for the grid, not the transformer, not the substation. Money cannot buy its way to the front of a line made of copper and concrete. Then there's water, and here I'll be more careful than the internet usually is. Cooling does consume water, and has triggered real protests from Arizona to the Netherlands. But the honest number is half of 1% of all industrial water used worldwide. A real local issue in dry places, not the global catastrophe your feed says it is. What people should actually be angry about is on their electricity bill. What you cannot skimp on is uptime. This entire business stands on one promise. It never goes down. Redundant power, generators, batteries, redundant cooling, redundant network. So you pay permanently for equipment whose job is to do nothing in case the thing next to it fails. Almost no staff, enormous capital, and an electricity bill that would embarrass a small city. Running at full tilt, whether or not artificial intelligence turns out to be worth it. So why does anyone want this? Because the demand is unlike anything in modern real estate. Malls have empty units. Hotels have empty rooms. Offices have entire empty floors. Data centers have a waiting list. And look at what the shovel seller earns off it. NVIDIA's data center segment brought in $51.2 billion in a single quarter, up 66% from the year before. Then look at the landlords. Over 12 months, the big data center property companies delivered total returns of roughly 39, 41, and 45%. Digital Realty, Equinix, Iron Mountain, 40% from being a landlord. In a decade where being a landlord to anything else has been a slow grind. And those landlords are structured as real estate investment trusts. As long as they pay out most of their profits to shareholders, that money isn't taxed at the company level first. The tax code likes this business. So here's the brochure, and it's a beautiful one. A building fully leased before completion. Contracts running 10 and 15 years. And genuinely unusual tenants. A mall leases to retailers who go bust in recessions. An office block to companies that shrink. This building leases to the largest, best capitalized corporations that have ever existed. Which changes what you're actually selling. You're not selling computing. You're selling a promise to a bank. Here is 15 years of contracted revenue, signed by one of the strongest credits on earth. That piece of paper is why the debt for these buildings exists. And notice the beautiful thing about that structure. You don't need artificial intelligence to work. You don't need your tenant's product to find customers or their models to get better or any of it to be worth the hype. You just need them to keep paying rent on a contract they signed. You've been sold a bet on technology that looks, on paper, like a bet on nothing at all. The safest real estate in the world. And every word of it is true. That's what makes it dangerous, because none of it tells you which side of the table you're sitting on. The trap in this business is not the building. The building is fine. The building will still be standing in 30 years. The trap is what you put inside it. A data center shell is designed to last decades. The chips racked inside it are useful for 4 to 6 years. NVIDIA itself points to 4 to 6 year depreciation schedules. So you have a 30-year box wrapped around a 4-year asset. And the 4-year asset is the part you actually paid for. Watch what that does to the resale market. NVIDIA's H100 systems, The chips that built the modern AI boom have reportedly traded at less than half the price of new by year 3. Half in 3 years for the most sought-after industrial product on the planet. It's a melting asset. You are buying an ice sculpture and putting a roof over it. And nobody actually knows the melting rate. Between 2020 and 2024, the big technology companies kept extending how long they assumed their servers would last, which flatters profits because you spread the cost over more years. But actually, here's the flip. In 2025, that consensus broke apart. Amazon shortened the useful life it assumed for a slice of its servers. Meta extended its estimate further. In the same year, in the same industry, two of the best-informed buyers on Earth moved in opposite directions. When the people who buy the most of something can't agree on how long it lasts, you are not making an investment. You're making a bet and calling a spreadsheet. In fairness, there's a counter-argument. Chips don't die, they cascade. A chip bought for training the newest model gets demoted to premium fast responses, then to bulk, cheap workloads. Handled well, that can stretch economic life to 5, 6, 7 years. It also requires you to keep finding someone who wants last-generation silicon in an industry that spent 3 years teaching everyone that only the newest generation matters. And here's the part that hurts. It isn't only the chips that go obsolete. It's the room. Every chip generation runs hotter and hungrier per rack than the last. A building designed for the power density of a few years ago can be physically unable to serve today's hardware. Not full, not old, just wrong. You can own empty space you cannot rent in a building with no vacancy in its market. So the treadmill isn't optional here either. To stay leasable, you keep repowering and recooling a building you already paid $2 billion for. But here's where it gets interesting. Because while you're doing all of that, the melting chips, the obsolete cooling, the 7-year wait for power, somebody is getting paid calmly every single quarter. Several somebodies. Every video in this series ends up at the same question. When the money comes in the door, who touches it first? Here, the answer is the most brutal one we've found yet. 3 people are ahead of you, and not one of them carries your risk. Start with the chip maker. NVIDIA's gross margin runs around 75%. Of every $4 that facility spends on its most important component, 3 stay with the seller. And notice the structure of that sale, because it's the whole game. NVIDIA sells you the chip. It does not take a share of what the chip earns. Whether that silicon pays for itself twice over or sits dark in a bankrupt building, the invoice was settled on delivery. If that sounds familiar, it should. It's the coaster manufacturer from our theme park video and the flag on the hotel. Second in the queue, the landlord. If you lease your building from a property company, that rent is due on the first regardless of whether your tenant's artificial intelligence product ever finds a customer. That's where those 40% returns come from. Not from the technology working, but from the lease existing. Third, the utility. Your electricity bill is charged on consumption. And consumption is the one thing you can't reduce without switching off the machines your entire revenue depends on. The meter is senior to your profit. And then fourth at the back, you, holding the debt, the depreciation, and one more thing we haven't discussed, which is the most dangerous of all, your tenant. In every other asset in this series, you have thousands of customers. A theme park has 10,000 families on a Saturday. A casino has a floor full of strangers, and none of them can hurt you alone. A data center has a handful of tenants, sometimes one. Look at CoreWeave, one of the biggest specialist AI cloud companies in the world. In its most recent full year, Microsoft accounted for about 67% of its revenue. No other customer reached even 10%. 2/3 of a company built on billions of borrowed dollars, resting on the purchasing decisions of one client. And this is not a small operation. 43 data centers, around 850 megawatts running, roughly 3.1 gigawatts contracted. Enormous and enormously concentrated. Now watch the second twist, the one that should worry an owner most. Much of the capacity Microsoft reserved was reportedly being used to run OpenAI's workloads. Then OpenAI signed directly with CoreWeave, reportedly around $15 billion worth. The customer's customer became the customer. The middle disappeared, which tells you something uncomfortable about your position. Your tenants are not just tenants. They're each other's suppliers, each other's competitors, and increasingly, builders of their own facilities. Every one of them would rather own what you own, and they have more money than you. So the industry has assorted itself, exactly like every other one in this series, into two species. The ones who collect on delivery, on the lease, on the meter, and the one who carries the debt, the depreciation, the tenant, the 7-year wait. Guess which species a first-time owner automatically joins? Everything so far assumes one thing: that demand keeps climbing, that the tenants keep signing, keep expanding, keep needing more. Watch what happens when that assumption twitches. February 2025. An analyst note lands reporting that Microsoft has terminated leases with at least 2 operators, a couple of 100 megawatts, walked away from around 100 megawatts of further deals, and abandoned at least 5 parcels of land lined up for future sites. Construction on a Wisconsin project meant to serve OpenAI is paused. Think about that for a second. Weeks after the same company announced an $80 billion building year. The company's response was not a denial. Satya Nadella said plainly that there would be an overbuild, while promising to lease heavily again in 2027 and 28, which is an extraordinary sentence if you own a half-finished building. Your tenant is telling you, in public, that the market will have too much of what you're currently pouring concrete for, and that he'll be back later when it's cheaper. And this is a company that has run this play before. When it cut back a $48 billion spending program on the metaverse, Meta canceled data center leases the same way. Demand in this industry is not a trend. It's a decision made in a boardroom you will never sit in. But that's the ordinary swan, the one every capital-heavy business faces. There's a second one here, and it's genuinely new. This is the first asset in this series that can be killed by people who are not its customers. March 2026 and through that whole spring. Reportedly, at least 75 projects worth about $130 billion blocked or canceled in a single quarter. Not by the market, by neighbors. In Monterey Park, California, voters passed a ballot measure permanently banning data centers, the first city in America to do it outright. At least 67 other towns have temporary bans in place. And then the heart of the industry itself. Loudoun County, Virginia. Around 250 data centers already, more than 100 projects in the pipeline behind them. On the 22nd of July, 2026, its board voted to have staff research whether a moratorium on new data centers would even be legal, with a decision scheduled for September. The capital of this industry is openly discussing whether to stop letting the industry exist there. So why are they so angry? Not the noise, though there's noise. Not the look of them, though they're not beautiful. Follow the electricity bill. Between March 2021 and March 2026, residential electricity prices rose 94% in Washington, D.C., 74% in Maryland, 73% in Maine, and 58% in New York. Nationally, retail prices are up around 40% since 2021, the fastest stretch on record. Now, prices rise for many reasons, and it would be dishonest to pin all of that on data centers. But the source number is this. Data center demand was a primary driver of about $23 billion in customer price increases that stay on people's bills until at least the end of 2028. $23 billion moved from a technology industry's cost line onto the electricity bills of people who will never use the product. And here's the thing about that arrangement. Those people vote. In county elections, where turnout is low, and a single motion on a Tuesday night can freeze $1 billion of construction. A theme park fails because it rains. A hotel fails because the economy turns. A casino fails because a whale stops flying in. Those are all market risks, impersonal, and at least in principle, insurable. This asset can fail because 200 people show up to a planning meeting. Read that again. The single largest risk to the most capital-intensive building of the 21st century is not technological, and it is not financial. It's civic. It's whether the neighbors decide they've had enough. And notice one more time who is untouched by all of it. The chip maker was paid on delivery. The landlord holds a signed lease. The utility already banked the connection fees. The moratorium lands on exactly one person, whoever owns the land, the debt, and the half-built shed. So, should you buy a data center? What you'd really be buying is an electricity contract with a building around it. Not a technology asset, not even a property asset, a claim on power, and a place to put it. Because strip the site down to what's genuinely scarce, and it isn't the concrete. Anyone can pour concrete. It isn't the chips. Those are for sale to anyone with money, and they're melting anyway. It's the interconnection, the right to draw 100 megawatts off that grid at that spot. That's the thing with a 7-year queue in front of it. That's the moat. In the good year, a fully leased building, investment-grade tenants, contracted revenue for 15 years, and a market with 0.5% vacancy. Genuinely spectacular economics. In the bad year, your one tenant renegotiates or builds its own or simply doesn't renew. Your chips are worth half. Your cooling can't serve the new hardware, and the county has scheduled a vote. And in both years, good and bad, the same 3 parties get paid before you do. The chip maker on delivery, the landlord on the lease, the utility on the meter. The owner eats last. You've heard that in every one of these videos, because it's the only rule that never changes. But the real lesson is sharper, and it took the whole video to earn. In every other asset we've looked at, the scarce thing was obvious. In a hotel, it's the land. In a theme park, it's the crowd. In a casino, it's the license. Here, everyone looked at the computers, and the computers were never the scarce thing. The scarce thing was the wire. A boring, unglamorous, decades-old piece of public infrastructure that nobody was thinking about while everyone was arguing about chips. Which is why the smartest money in this business has quietly stopped trying to own the computing at all. It's buying land next to substations. It's buying queue positions. It's building its own generation on site, because that's the only way to skip a 7-year line. That's worth sitting with. In the most futuristic industry on Earth, the winning asset turned out to be a 19th century one, the ability to make electricity and the right to move it. So by the dream itself, the gleaming halls, the blinking lights, the sense that you own a piece of the future, and you'll find you've bought a shed full of melting inventory on a wire you don't control, rented to a tenant who'd rather be you. Hold the whole picture in one frame. A $2 billion building where half the cost is plumbing for electricity. Contents that lose half their value in 3 years while the box lasts 30. 3 parties who take their cut before the owner sees a dollar. 1 or 2 tenants who are also your rivals. And underneath all of it, one wire with a 7-year queue running to a substation that a county board can vote to stop expanding. And somewhere out past the ring road, behind a berm and a line of young trees, a building with no windows is quietly turning a small city's worth of electricity into answers, while the person who owns it refreshes a planning commission agenda and waits. That's the economics of owning a data center. Now it's your turn. Which business should we put under the microscope next? A ski resort, a shipping port, a private hospital, a vineyard, whatever you're curious about, drop in the comments. The best suggestion becomes a future video. Thanks for watching. And if you'll never drive past one of those windowless buildings the same way again, subscribe. The next breakdown is already on the drawing board.